Okay, let's talk about what you just copied. There's two types of density in geometry. There's volumetric density, when that is how much mass is located within a specific volume of space. So, for example, the Diet Coke example, the regular Coke sank in the tub of water because it had more sugar in it. That means it's more dense, where the Diet Coke had artificial sweeteners and it made it a little bit smaller. That's why it floated there, okay? So for this is two examples of volumetric density. Remember, this will come from the formula. The density is the mass divided by the volume. So the mass is going to be the grams and the volume is going to be cubic centimeters, or how much it weighs per cubic foot. So you're going to use that formula. Now, when you get into area density, this would be like a social studies class. This is the quantity of something per unit of measure, and that can be how long something is, or it can actually be the area of what it's taking up. So a classic example will be population density. This could be the number of people per square mile, plants per square mile, or animals. So it's going to be the number of something over the area. And then quantity density is like an air conditioner. Is the air conditioner big enough to cool the room? So it's going to be in BTUs per cubic foot of airspace. Same thing could go with heat. If you have gas heat, is the heater big enough to heat the room? So we're going to look at two examples of these. The first one says, this is data about two approximately cylinders, they're pieces of wood, shown in the table. Determine which is denser and by how much. So you're given two types of wood, a Douglas fir and an American redwood. You have the diameters of each, you have the height of each, and you have the mass of each. So what we need to do is we need to compare the two, okay, and we're going to calculate their density. So the first thing we need to do is we need to find the fir volume. So remember, these are both cylinders, pieces of wood, and they're telling us something. So if this diameter is 6, the radius is 3. So the fir volume of the cylinder would be base area, so pi radius squared times the height of 17. Now, we are going to keep everything in terms of pi to make our calculations easier. So that is going to be 9 times 17. So that is going to be 153 pi. Now we have all of the information to calculate the density. So the density is mass divided by volume. So the mass is 254 kilograms divided by 153 pi centimeters cubed, cubic centimeters. So if I now take that 254, divide by 153 pi, remember, put parentheses or use the fraction key, we are going to get approximately 0.53 kilograms per cubic centimeters. Now, we are now going to do the same process for the American redwood. We first have to find the volume of that. We are going to use the same formula because it's here. Now notice that it is shorter, but it is wider. So we are going to do pi radius will be 4. So pi radius squared times height. So for this one, we are going to get 4 squared times 12. So we are going to get 192 pi. And this was going to also be cubic centimeters for the volume. So now, calculate the density for the American redwood. It is 271 kilograms divided by 192 pi cubic centimeters. So we are going to type that in on the calculator. So 271 divided by 192 pi, and it is approximately 0.45 kilograms per cubic centimeter. Now the question states which one, determine which is denser, and then by how much. So for this one, we are going to say the Douglas fir is denser by, and then we're going to calculate by how much. We are going to take our calculator. We're going to type that one in. We are going to subtract this one. So it is by about, we'll round to the nearest hundredth, 0.08 kilograms per cubic centimeter. So that is how you would do a volumetric density. So even though this one is probably going to be, this one's shorter, this one here has more density simply by the math. Now we are going to look at an area population density. So it says Tennessee has a population of probably about 6.5 million. Its territory can be modeled by this trapezoid as shown in the figure. It is not a parallelogram because these are not quite parallel, so we're going to say it's a trapezoid. Each unit on the coordinate grid represents 1 mile. Find the approximate population density of Tennessee. So the first thing we need to do is think about the formula. The formula is population divided by area, square miles. So the first thing we would need to do is we need to find the area of Tennessee. Now remember, it stated that it is a trapezoid, so the formula will be 1/2 the height times the bases added. So we are going to have to come down here to this graph and figure out the height. Now the first thing I notice is this is not scaled by ones. It goes 1, 2, 3, 4, 5 to get to 200. So if we divide 200 by 5, that is going to be a 40. So we need to realize that this is scaled by 40. Now, in order to get the height, we can look this way. And if that is the height right there, and it's scaled by 40, that is 3 units. So the height can be a 120. Next, we need to do the bases. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is going to be 400 miles. And this is 1, 2, 3, 4, 5, 6, 7, 8. So this piece right here is going to be 8 times 40 for 320. So 400 plus 320. Now this is going to give me the area approximately of Tennessee. So if we type this into our calculator, we are going to get half of 120 times 700. So we are going to get approximately, except I typed that in wrong. Sorry about that. This is actually 720. That's the better answer. We are going to get the area approximately 43,200 square miles. Now, we are now ready to calculate the population density. So we were going to say population density equals. Now remember what we're doing. We're going to do the population of Tennessee divided by the area of Tennessee. So the population of Tennessee, according to the problem, is 6,495,978. So that is people divided by the area of Tennessee, 43,200 square miles. We are going to do this on the calculator. So we will type this in, divide that by 43,200. So since we're talking about people, we will say that the population density is about 150 people per square mile. So, recapping this lesson, there's 2 types of density that we will talk about in geometry. We can do volumetric density when it's talking about the density of two objects. It could be light, it could be heavy, or we can actually talk about population area distance. So population density is just taking the number of people or objects over the square miles.